Hey friends, Dr. Borole is here. Today we are continuing our learning with thermal sensors. Today we will see the thermocouples. Thermocouples are the active sensors. They will generate the output voltage which is proportional to the temperature difference of light. Thermocouple works on the principle of Seebeck effect. It uses two different metal junctions kept at two different temperatures, say T measurement and T reference. Whenever the junctions of two dissimilar metals are kept at two different temperatures, there is a generation of thermal EMF in the two metal, and the thermal EMF generated is proportional to the temperature difference between the two junctions. There is no need of any external DC power supply for its operation. Let us see the construction of a thermocouple. Here, the following figure shows a thermocouple consists of two metal wires. One is chromel and another is alumel. Chromel is shown by the wire X and alumel is shown by the wire Y. They are joined at junction J1 called as measurement junction or sensing junction. The temperature of the sensing junction is marked as T sense. The other two terminals are connected to the isothermal block which is kept at the temperature of T reference. From these isothermal block terminals, the chromel and alumel wires are connected further to the measuring system or a meter by using copper wires. Sometimes special wires are used for the thermocouple so that there should be no additional thermocouple developed at the reference block. That is, chromel and alumel wires are used for conducting the signal from the thermocouple to the measuring system. This is chromel alumel thermocouple, which is also well known as K type of thermocouple. Here, junction J1 is kept at T sense and junction J2 and J3 is kept at temperature T reference. Since from the Seebeck effect, we know that when the two metal of different properties kept at two different temperatures, there is thermally generated charge carriers and they move due to the temperature difference. And therefore, there is a generation of thermal EMF, which is proportional to the temperature difference. And this property is used to measure the temperature at the sensing junction. Let us see the Seebeck effect, also called as thermocouple effect, somewhat in detail. The first requirement of a thermocouple is that the two wires used for the thermocouple should be of two dissimilar metal. If similar metals are used for the thermocouple, there is no thermal differential EMF is generated. So, differential EMF is generated only when the two metals are dissimilar. See here in the figure, the animation is shown. Whenever the temperature is applied to the hot junction or measuring junction, the electrons acquires the energy and they move towards the cool end. But due to the property of the material and conductivity of the material, since materials are different, their speed is different in different materials. So here in chromel, the speed of the electron moving to cold junction is lesser than alumel. And therefore, instantaneously we will see that there is more accumulation of electrons at the cold junction in alumel than chromel. And therefore, More negative potential is developed at the cold junction of alumel compared to chromel, and therefore there is instantaneous differential voltage developed between the two ends of alumel and chromel respectively. Whereas the chromel wire is a positive wire and alumel wire is a negative wire. The same thing is shown in the operational diagram. You can see here the motion of electrons are faster in alumel, and therefore the end of the alumel at the cold junction is more negative instantaneously compared to the chromel cold junction terminal, and therefore instantaneously the chromel terminal becomes more positive than alumel terminal, and therefore there exists a potential difference between the two wires, which is proportional to the difference between the two junction temperatures. Here in the figure, you will see the measuring junction JM is at the temperature Tm, and the reference temperature is say Tc. Vm1 is the voltage induced in chromel, whereas Vm2 is the voltage induced in alumel wire. Therefore, the output voltage between the two terminals X and Y is VO is equal to Vm1 minus Vm2. If both the wires are of same metal, then Vm1 and Vm2 are same, and therefore output voltage is 0. And therefore for thermocouple, both the wires should be of different material composition. Normally, the reference temperature is kept at 0 degree centigrade, and therefore reference temperature or reference junction is also called as cold junction. Chromel and alumel thermocouple or K-type thermocouple have two leads, negative lead and positive lead. Alumel is a negative lead and chromel is a positive lead. The following figure shows the characteristic of the thermocouple. Here on x-axis there is a temperature in degree Fahrenheit, and on y-axis there is a output voltage from the thermocouple. This characteristic is particularly of K-type thermocouple, that is chromel alumel. The range of K-type thermocouple is from minus 330 degree to around 2460 degree centigrade. The accuracy of the thermocouple is plus minus 5 degree Fahrenheit. Various other types of thermocouples characteristics are shown in figure B, like type E, type J, type M, type N, and type T. You will notice one thing from this characteristic, that the characteristics are not very linear, whereas range of measurement is quite wider compared to RTD. But the characteristics are non-linear, and therefore thermocouple needs a linearization of the characteristics while using over the wide range of temperatures measurement. Following table typically shows a standard chart of K type of thermocouple sensitivity, that is output voltage with respect to temperature. All the voltages here shown with respect to reference temperature of 0 degree centigrade. You will see here the temperature is shown from 0 degree to 100 degree. At 0 degree, you will see the output voltage is 0. Means when measurement junction temperature is 0 degree and reference temperature is 0 degree, since there is no temperature difference, the output voltage is 0. You will see that the output voltage at 50 degree is 2.023 millivolt. Whereas at 100 degrees C here, the output voltage is around 4.096 millivolt. This figure indicates again the same characteristic curve for K type of thermocouple. At 100 degree Fahrenheit, the output of K type thermocouple is 1.566 millivolt. Whereas at 120 degree centigrade, it is 2.023. At 300 degrees centigrade, it is around 6.138 millivolt. So, when we measure the temperature, we can first measure the voltage from the thermocouple, and then from the chart we can find out what is the measured temperature is. Whereas the measurement system, computer or microcontroller, that is having built-in data table which will continuously take the measurement of input voltage from the thermocouple and locate the corresponding value of a temperature from the data table present in the memory. This way, the microcontroller can estimate the current temperature using thermocouple. In practice, the thermocouples are available in different shapes. Typical thermocouple shapes are shown here. The rod type of thermocouples are shown. Here in the first figure, the basic thermocouple of two different wire is placed inside a tube and the measuring junction is placed at the point of contact of the assembly. Whereas the connecting wires are connected to carry out the thermal EMF generated from thermocouple to the measuring system. Here, this is a terminal connection block so that from this you can connect the wires and you can continue it further to the next part of the measuring system. So thermocouple actually look like this in practice. Various material types and ranges of the thermocouple. This is just for additional information. We have listed here various types: type B, type E, type J, type K, type N, R, S and T type of thermocouple. Whereas K type thermocouple is quite common because it is more linear, means non-linearity is less. It is made up of chromel and alumel. Chromel wire is a positive wire and alumel wire is a negative wire. Its sensitivity is in between 28 microvolt per degree centigrade to 42 microvolt per degree centigrade. And its operating range is approximately from minus 250 degree to plus 1250 degree centigrade. Depending on the requirement of the measurement temperature range, you can select the appropriate thermocouple. For example, if you want the temperature measurement more than 1250 degree, then you can go for type B thermocouple. That is platinum rhodium thermocouple, which can capable of measurement of temperature up to 1820 degrees centigrade. The sensitivity of the thermocouple element is given by S is equal to VO by T, where VO is the output voltage and T is the temperature measured at the measuring junction. And that is given by a series A plus BT plus CT square. Higher order terms are ignored. And this equation tells us that the sensitivity of the thermocouple is not a linear function of temperature. It is also function of square of the temperature and higher power of the temperature. And therefore, there is existence of non-linearity. This non-linearity can be further rectified in the measuring instrument by compensating it. Various advantages of thermocouples are: thermocouples compared to other sensors, say RTD and thermistor, they can have wider temperature range, minus 200 to 1100 degrees centigrade, for example. RTDs have the temperature measurement range below 650 degrees centigrade, whereas thermistor can be operational below 150 to 200 degrees centigrade. Therefore, for higher temperatures, thermocouples are the only solution. Thermocouple doesn't need any external DC supply because it generates the EMF on its own, and therefore it is also called as active sensors. It is having good sensitivity parameter, and therefore the output is significant and sufficient to be measured in the noisy environment also. Thermocouple have fast dynamic response. The limitations of the thermocouple. Obviously, we have discussed up till now the characteristics of the thermocouples are non-linear. So, additional linearization technique need to be employed in the control circuitry. Thermally generated EMFs are smaller compared to other sensors. Since the generated EMF is with respect to the cold junction temperature, and therefore cold junction temperature compensation must be required, because many a times and normally the cold junction temperature or cold junction may not be kept at 0 degree centigrade. It is kept at room temperature, and therefore the error due to keeping the reference junction at room temperature can be compensated of by adding a compensating junction. Typical application of the thermocouple is shown here. Here there is a process tank shown, and the vapor temperature is measured using a thermocouple. Here thermocouple is inserted inside the tank where the vapors are, and temperature that generates the thermal voltage that will be taken to the measuring system, and it will measure it, linearize it, and display it on the display. Now, comparison of various temperature sensors we have seen up till now. For example, you can go through this principle of operation. In RTD, resistance changes with temperature. In thermistor, again, the principle is change in resistance due to temperature. In thermocouple, there is a thermally generated voltage due to change in temperature. Type of transducer. RTD and thermistors are the passive transducers, whereas thermocouple is an active transducer. Let us see the temperature range. RTDs can be used up to 650 degrees centigrade. Thermistor can be maximally used around 300 degrees centigrade. But the thermocouple can be capable of measuring the temperature in thousands of degrees centigrade. Response time of RTD and thermistor is good, but in thermocouple it is excellent. Means it is fast responding. Cost of RTD is higher compared to thermistor and thermocouple. Out of that, thermocouples are the cheapest one. The accuracy of RTD is very good compared to thermistor and thermocouple. The size wise, RTD is large in size, and thermistors and thermocouples are physically smaller in size. The various material used for the sensors for RTD, platinum, nickel, copper and semiconductors can be used. Whereas for thermistor, copper constantan and iron constantan or chromel alumel can be used. Whereas in thermocouples, iron constantan and copper constantan can be used. Linearity characteristic wise, the RTD is mostly linear, whereas thermistors and thermocouples are more non-linear. For smaller range of measurement, RTD doesn't need any linearization or compensation, whereas thermistor and thermocouples always need the compensation. RTD is normally used for shorter temperature range of measurement, whereas thermistors mostly used in sensing the temperature limits, and it generally provides the output either on or off, whereas thermocouple can be used for linear measurements. That's all about the thermal sensor, friends. In the next session, we will see the gas sensors. Till then, bye bye.